Hey everyone, so let's solve this Leetcode hard problem, a number of flowers in full bloom. So the problem states that we are given a 0 index 2D integer array flowers, which denotes like flowers of I is having two values, start of I and end of I, which means that the ith flower will be in full bloom from this period, means from this start I to end of I, and both our values are inclusive here. Now we are also given a 0 indexed integer array people of size n, where people of I is the time that the ith person will arrive to see the flowers. Okay, so we are given means multiple flowers at the means the start and end points, means the period at which they will be in full bloom, and we are given this people array which denotes the time at which these ith person will be coming to see the flowers. Now we need to return an array of size n, which means each answer of I will be denoting what? It will be denoting the number of flowers this ith person will be able to see in full bloom. Okay, so when this ith person arrives as that particular time of people of I, then at that particular time, how many flowers are in full bloom? That is what we need to tell, and we need to tell it for each person. Okay, so hence we need to return a vector of means a vector array answer, and the length of flowers can go up to 5e4, and the values of start and end can go up to 1e9, as well as the number of people that we have is also 5e4, and the people can also means people of I can means the time can vary till 1e9. So let's see the given inputs here. So the first flower can bloom in the period 1 to 6. That means it will be blooming in this period from 1 to 6. Okay, now the second flower from 3 to 7. So this is the second flower, 3 to 7. Then we have 9 to 12. So this is the third flower from 9 to 12. And this is the fourth flower from 4 to 13. So from 4 to 13 we have the fourth flower. Now a person comes at time 2. So when a person comes at this particular time 2, how many flowers does it see? He will simply see this flower only. Okay, so only one flower. When a person comes at time 3, he will be able to see two flowers here. So two flowers. When a person comes at time 7, he will be able to again see two flowers here. So hence again the output is 2. And when a person comes at time 11, he will again be able to see these two flowers in full bloom, and hence for this person as well the output is 2. So hence we'll simply return this vector which has like the number of flowers each person will be able to see at this particular period of time. Let's see another input. So we are given the flowers. The first flower can bloom in the period 1 to 10. So we have the entire period from 1 to 10, and the second flower can bloom in the period at 3 only. So it is simply 3 to 3. Now when a person comes at time 3, he has seen two flowers. So he will be seeing two flowers. Similarly, second person also comes at time 3. So again flower 2, and the third person comes at time 2. So at time 2 only a single flower is there. So hence only the output is 1. So what do we see? Means if we try to mimic this image that we are given, if we try to mimic this into code, what will we try to do? We can simply know like if each flower, for each flower we have the start as well as we have the end. So we can simply maintain the values, and means for all values from start till end we can simply increase its frequency. Okay, the number of flowers that are present at this interval. For example, here the start to end, if it was 3 to 7, then at 3 will be increasing the number of flowers by 1. At 4 also number of flowers increases 5, at 6, at 7 as well. Okay, so we can simply iterate for all the start, means for all values from start to end, and we can simply increase the number of flowers present at each of these points. Okay, and we can do it for all flowers of I. Okay, now how will we maintain these indexes? So we know like we'll need to maintain a vector which will be like each index will be denoting the value of that flower at that particular index. Okay, so what will be the maximum size of the vector that we need to make? It will be the maximum endpoint that we have here. As we see, like the maximum endpoint was 13. Okay, here 13. So we can simply create a vector of size 14 and initialize it with 0. Okay, and now for the first flower we have from 1 to 6. So from 1 to 6 we can increase the values by 1. Then from 3 to 7 we can again increase the values by 1. Okay, so we can simply follow this approach. Okay, so what will be the size of vector that we'll be creating? It will be simply the maximum endpoint that we have. Okay, so maximum plus 1. Similarly here the maximum endpoint was 10, so we'll be creating a vector of size 11. Okay, as we created here 14. So once we create this vector, suppose we create this vector which is suppose prefix sum, which will be simply the maximum endpoint that we get plus 1 and initialize it with 0. Now we iterate through each flower. So we iterate in the flowers array. Now for each I, suppose from 0 to n, 0 to m, suppose if we have m flowers. So now for each flower we have this start as well as end. So we'll move this j from start to end. And what we'll do, we'll increase this prefix of j. We'll increase the prefix of j. Now once we have done that, then to find the number of flowers who are in full bloom for a person at which appears at any particular time, we'll be simply storing the value at this prefix array only. Okay, so suppose we have already created this prefix array. It will be simply initially, it will be what? It will be 0 at all places. Okay, like this. Then for 1 to 6, it will be increased by 1. So 1, 1, 1, 1, 1, 1, 1. Now other values, now from 3 to 7, it will be again increased by 1. So here also 1, 1, 1, 1, 1. So these values will become 2. Okay, 1 plus 1, 1 plus 1, 1 plus 1, 1 plus 1, and here it will have 1, 1. Now suppose there were only 2 flowers, and if a person comes at this particular time, then we will simply return the value present at this prefix. And that will be the value denoted by what? Denoted by the number of flowers in full bloom. So we can simply do this, and then we can, when people come, for each people, what you do, for all people from I 0 to n minus 1, the result will be what? Result of I will be simply the prefix of people of I. Okay, because at that particular time, what is the number of occurrences of that particular of flowers at this particular time, we'll be able to store it prefix and we'll be able to do it. So let's see the code first, and then we'll try to analyze the complexity of the approach. So this is the same approach. We first try to find out the maximum endpoint that we have in flowers. So we find out this maxi value, and then we create this prefix vector of size maxi plus 1. Now we iterate through each flower has its start as well as end time. We iterate from start to end and increase the prefix value. Now we create this resultant to store the result for each people. Now when we iterate through a people, suppose the maxi value that we had, means the flowers range was here, but a person comes at this time, which is lying much greater ahead. So that means there will be no flower ahead, right? Means any flower which lies in the range greater than maxi, means if any person comes at this time which is greater than maxi, obviously there will be no flower there. So we need to handle that separately, because means if we simply call prefix of x, then in that case we'll be getting a reference error, because this prefix of x doesn't exist because x is greater than maxi. Okay, so if x is greater than maxi, we can simply push 0 in our result, else we'll be pushing what? Prefix of x. Okay, and in the end simply return the result. So let's try to analyze the complexity of this brute force approach. So we see like the maximum means this maxi value will be getting till the end of I can go up to 1e9. Okay, so this maxi value can go up to 1e9, and as soon as we try to create a prefix of size 1e9, we'll not be able to create this. So this will obviously give us MLE before we encounter any TLE as well. And means even if we ignore this MLE, we see like for each flower what we are doing, we are iterating through for each start from start to end. So this loop can go up to 1e9. Okay, this J loop that we are doing. So it will be what? It will be size of flowers array into 1e9. So m into 1e9, and m can go up to what? 5e4. So 5e4 into 1e9. This is the time complexity of this approach. And obviously the space is also not allowed. Means this space is simply not allowed. So it will be giving TLE as well as MLE here. And first means since we are doing this initialization, so as soon as we try to do it, it will simply give MLE. So this approach is obviously not feasible, and hence we try to first let's try to means we know later we can try to avoid this MLE, but first we need to think of some efficient approach to update this, because obviously doing this is not feasible because we need to avoid this TLE. So let's try to first avoid the TLE, and then we'll try to avoid the MLE. Okay, so how do we avoid this TLE that we have? Okay, so why we are getting the TLE? Because we are iterating for all j from start to end. So this is a loop which runs in 1e9, and the overall complexity becomes m into 1e9. So now comes the concept of what? Concept of prefix difference arrays. Prefix difference arrays. So I hope you have heard about this num before, because we have used it in many problems earlier as well. If you are not, I will be like teaching you what this is. So whenever we want to increase all the values in a range from start till end, okay. So one way is to simply iterate for j from start to end, right? But that will obviously, since end can go up to 1e9 here, so this will obviously means run till 1e9 and will give TLE here. So we need to optimize this approach. So what do we do in prefix difference array is simply, instead of like means updating at each step from start to end, what we do is we update at start, means we know like at start the value is getting means starting to increase. So at this position we'll be simply marking it as +1. If we mark it as +1, that means the values are going to increase from this point onward, and it will be getting increased till this particular point. Okay, so at n plus 1 we can mark it as -1. That means till start to end it is +1, and as soon as we reach n plus 1 it will be +1 -1, it will become 0. So it will be neutral from this point onwards. Okay, so this is what we do in prefix difference array. What do? We increase the prefix of start, means at start we increase, and at prefix of n plus 1 we simply decrease. Now we'll do this for all the flowers. Okay, we'll be doing this for all the flowers. So let's see how this will get affected here. So for example, if we have this as the input, so what we'll do, we'll increase by 1 at this step and decrease by 1 at the next step. Okay, and for 3 what we'll do, we'll increase at +3 and end +1. So at 4 we'll be decreasing it by -1. Now what we'll do, we have created the difference array. Now we need to take the prefix sum. Okay, so now when we'll take the prefix sum of this modified array, it will be giving us the final count. So if we take the prefix sum, it will be simply what? +1, then +1, then previous plus current. So it will be +2, then current plus previous. So it will be again +1, then +1, +1, +1, +1, +1, +1, and +1 -1, it will become 0. So we see like this is the count of flowers at each step. 1, 1, then 2, then 1 till end, and afterwards 0. Okay, so using this prefix sum plus difference, we will be able to calculate the number of the flowers at each index without iterating for j for each start to end. So what do we means? We will be able to avoid this TLE that we were doing at each step. We will be doing the prefix sum at the end. Okay, so let's see this modified approach. Means then we'll try to avoid the Emily. Means Emily is still there because we have created a prefix array vector of size means 1e9. So obviously the Emily will be there, but we have avoided this thing that we have done. So we have progressed, means a little progress that we have tried to make. So let's see the modification that we did. So this everything else remains the same, means the calculation of maxi remains the same. We have initialized it with maxi +2 because since end can go up to maxi, so since we need to access end +1, so end +1 can go up to maxi +1. So hence we need to store values till maxi +1. So hence we need a vector of size maxi +2. Okay. Now instead of iterating for all j from start to end, what we'll do, we'll increase at start and decrease at n +1. And after we have done that for all the flowers, what we'll do, we need to take the prefix sum. So we'll be taking the prefix sum, means adding the previous value accumulated so far at the current index. So it will be simply prefix of j. We will be starting from 2 because at 1 means it is not, means at 0 there is no flower, because start we see like the index constant is start and I start and end starts from index 1. Okay, so this 0 doesn't matter, so one value will remain the same, and from 2 we can accumulate the sum accumulated so far and move it forward. Okay, so in this manner now prefix of x will be storing the number of flowers present at time x. We'll simply iterate through, means this everything remains the same, only this part means we have modified to avoid the TLE that we have gotten. And yeah, now still you might say like we have avoided the TLE in this position, because now this loop runs in big of M, but obviously this prefix sum will be still be taking big of 1e9. Okay, and why it is taking big of 1e9? Because since we need to modify the entire prefix, and the prefix has a size of 1e9 only. So before that, still it will give Emily, as well as for this loop it will give TLE. So what is the problem currently? If we are able to reduce this prefix size to something which is iteratable, then we'll be able to avoid this as well, because this we have already modified, means optimized. So if the prefix size can be reduced, then we'll be able to iterate through the prefix as well. So this TLE will also be avoided. So now how do we avoid TLE here? How do we first avoid creating such a large vector, and then how do we avoid TLE as well? So let's try to see in that direction how we'll be trying to avoid it. So we see, like, currently what we have done is we have created all, means a vector which has values from 1 till maxi. Okay, and we'll be able to get the number of flowers present at any time at any x by using this vector. But is it really required? Means we have created a vector of size 1e9, but the size of people array that we have is 5e4 only. So out of the 1e9 vector that we have created, only 5e4, means at max these 5e4 unique asks can be done, right? So means all other, means these extra allocations that we have done is really not required. We are only required to, means, store those information about those indexes which are present in this people, as well as this start, as well as this end. Okay, so apart from all these values, means we are start, we have end. So if we simply try to store information at these indices and avoid the information about start plus 1 till all the position till n minus 1, because suppose the start is 1 and end is 1e9, we can simply store that at this point we have a plus 1 and at this point we have a minus 1, but we do not store the information from 2e2 till 1e9 minus 1, that all these positions should be increased by 1. Okay, we do not explicitly store it. So how can we avoid this scenario? Because we know that we only need to store the, means the index time which is, means optimal to store is the time at which the people are coming, and the people can come at most at 5e4 positions. So what we can do is, instead of like creating a vector, how can we optimize the space here? So we definitely need to store the count of, like, number of flowers at a particular x. Okay, but instead of, means these redundant values which will not be using at any time for people as well as for updation, we can avoid storing that. So what, means currently what we are storing? We are storing start and plus 1, right? We are updating at these parts only. So hence we can simply try to store these endpoints only. So if m is the flower size, at max we'll be storing 2m values. Okay, and if, means apart from that, if we have n different people, then we'll have 2m plus n different time points that we need to store. Okay, so instead of storing the entire time from 1 to 1e9, we could optimize it to store only those endpoints which are important here. And what are those endpoints? Which were, means at here we are increasing, at here we are decreasing. Okay, so let's try to store at these endpoints only. And since we only also need to like find out the number of occurrences at for a particular people, so we can store that if this, means condition is already not, means if suppose we had the index as 1 to 4 and 2 to 6. Okay, this was the index, and a person is coming at index 2 and index 3. Okay, so how will the prefix look? Means how will be looking? It will be looking, suppose we create a map, we'll create a normal map for start endpoints as well as the upload. So we'll update MP of 1 with plus 1. So MP of 1 will become 1. Then we'll have MP of 2, means let's try to go in a sorted manner. So this is the range from 2 to 6. So at this point we'll be increasing it by 1. So MP of 2 will become 1. Then at MP of n plus 1, so n plus 1 will be 5. So MP of 5 will be minus 1, and MP of 6 plus 1, 7. So 7 will be minus 1. Okay, these are the updations that we need to do. Simply store. So these will be the 2m points. Now a person comes at time 2. A person comes at time 2. So what do we need to do? We need to take the prefix sum. So let's try to take the prefix sum. So prefix sum will be what? It will be 1, then 2, then it becomes 1, and then it becomes again 0. Okay. So if a person comes at time 2, MP of 2 stores what? MP of 2 stores 2. So that means at time 2 we have 2 flowers. So for time 2 we will be having 2 flowers. Now let's try to calculate the information for time 3. So we see like this 3 was not part of the 2m endpoints that we tried to store in map. Okay, so now how do we calculate information for this particular 3 which is not already present in map? So means there can be multiple ways. You may like think about we can find out this 3 and find out the lower bound of it, and means find out the first value which is just smaller, and that will be the same count, means the count of this value will be the same count for 3 as well. So we can definitely do that, but that is means this calculation is redundant here. We do not need to store these values. Why? I will be explaining you a pretty good approach here. Like instead of finding the first value which is just smaller than 3 and the result will be simply the same, means for 3 we will find this value 2, and for 2 the result is 2, so for 3 also the result will be 2. It is means it is good. But how do we, like instead of finding out the lower bound, is there a better approach? So yes, it does. We know like these 1, 2, 4, 6 are part of this, so we have updated it with these values. But we know we can simply iterate through these values and see like if this 3 is not a part of this 2m endpoints, we can simply update this MP of 3 as 0. So suppose we had 2, 3, 5 as well. So then we can simply, means 2 is present in map, so good. 3 is not present in map, so we can simply update MP of 3 with 0. 5 is not present in map. 5 is present in map. Yes, it does. So will not be updating it. Now suppose it was like at time 7. So 7 is not present in map. 7 is present. So we'll not update it. But suppose it was 9. Okay, 2, 3, 5, 9. So 9 is present in map? No. So we can update MP of 9 with what? 0. So now if this is the case, then what will happen? This will become MP of 1 will be 1. MP of 2 will be 1. So it will be 1, then 2. Then for 3 we have 0. Then for 5 we have -1. Then for 7 we have -1. And then for 9 we have 0. Okay, so suppose this was the case. Now we do the prefix sum. Again, let's try to do the prefix sum. So we'll have having 1, 2, 2, 1, 0, 0. So now all the values that the people will be coming will be simply able to access it from the map itself, because now this value will be existing in the map. So instead of finding this prefix, means lower bound separately, means finding the first value which is just smaller than this and then calculating the result, so that will be quite, means it is easy, but it will be means cumbersome. You can simply mark it those values as 0 and simply do the prefix sum that we already need to do. Okay, so now when we need to find the answer for 2, it will be stored at here, so 2. For 3 it will be stored here only, 2. For 5 it is already stored as 1. For 7 it is already stored as 0. For 9, since we marked it as 0, so it will be already present in map, so it is 0. So in this manner, what you will do in the map, we'll only have how many values? We'll have 2m plus n endpoints. This 2m endpoints and n unique people. So if all the endpoints are distinct, then we'll have these many values, and hence we'll be able to avoid the MLE that we are having for creating a vector of size 1e9. Instead of that, we will simply use a map to store information about only the endpoints. Okay, and since the map will be storing the information in a sorted fashion, after we have stored the information in this map, then we can take the prefix sum. Okay, and how will we take the prefix sum? We can means simply iterate, maintain the last sum that we have accumulated so far, and we'll be updating means at 1, so we'll be updating 1 plus 1. Then here -1 plus 2. Then -1 plus 1, so 0. Okay, so in this manner we'll be able to means maintain the accumulated sum. So now I hope, like since we'll be able to calculate the prefix sum as well in order of 2m plus 1, so we will be able to avoid TLE as well, and as well as we will be able to avoid MLE as well here. So let's try to see the approach as well as the implementation for this approach. The implementation is purely based on the prefix difference array concept only. Means this optimization was very crucial, because once we know that we will be using prefix difference array, then means finding out that instead of a vector we try to use a map is not pretty difficult. But thinking about this part means knowing about this part is crucial. So that's why this prefix difference array is concept is very important. Let's try to see the implementation. So we simply create a map. Now we iterate through each flowers, and at start will increase, at end will decrease, and plus 1 will decrease. Now we'll iterate if means iterate through people, and for the people which are not already present in map, if this people is not already present in map, we'll simply mark it as 0. Okay, so that now it is a part of the map, and while we are taking the prefix sum, its value gets updated, and then we'll be able to simply access it without finding upper bound or lower bound. Okay, so we initialize the last value. Now we'll be doing prefix sum. So mp of it dot first will be increasing the accumulator so sum so far for this value, and then this prefix will be updated. Okay, so last will be updated with this value. So now for the next value will be means it is simply the taking the prefix sum. So we'll take the prefix sum, and once we have taken the prefix sum, we'll create this vector result and push the means mp of it. We will be able to directly access it, and in the end return the result. So now we are means the size of this will be till 2m plus 1, which is order of like m and n can go up to 5e4. So overall it can go up to 1e5, and hence this will be order of 1e5 as well. Hence space complexity as well as the time complexity means space complexity would be order of 1e5, and the time complexity would be 2m plus n log 2m plus n. Okay, because we have used ordered map here. So this is the most optimized approach for this problem, and this will be like I hope like you were able to follow along how we tried to just initially do the brute force. Then we tried to avoid this TLE that we had, because having TLE means there is a flaw in the logic, and then we try to avoid the MLE by means simply optimizing the space based on like storing only those endpoints which are useful. So we simply try to use an ordered map, and then we are done. So let's try to submit this code here. So this is the same code that we discussed. Let's try to submit it, and then we'll try to submit the code that we discussed of MLE as well. And like I will show you live how that code gives us MLE here. So you'll see like this is the code that we discussed. So as soon as we create this vector prefix of maxi plus 2, we'll be getting this MLE. As you can see, it test case 33. Why MLE? Because these values are very large. So the maxi that we'll be having, it may be of the order of 1e9. So that's why we have simply means even if the size of flowers is not very huge, but we have got MLE because this maxi value will be very large. Okay, and then this initialization will not be able to do. So I hope like the entire approach as well as the discussion was fruitful and you learned something new here. And if you did, make sure to like as well as subscribe. And if you yet have any doubts remaining in any of the concepts discussed, then make sure to comment down. I will be happy to respond. Thank you so much for watching.